Finding zeros, as we've said before, is a fundamental question about a polynomial. When is that polynomial equal to 0? Now, in most of the cases we've seen so far, it's easy because we either have a nice function, like a quadratic polynomial, a linear polynomial, or we have something already in its factored form. Occasionally, though, more often than not, in fact, it is not easy to find a zero of a polynomial, so we need some tools that will help us find them. One such tool is what's called the intermediate value theorem, and I'm going to draw a picture sort of illustrates what's going on because it makes some intuitive sense. So if we have a polynomial, okay, and I don't necessarily know what it doesn't matter what it looks like. Now, looking at this graph, I see that this thing has a 0, right? I see that this has a 0, okay? But that's because I can graph it, okay? What would happen if I wasn't able to graph it? How would I be able to tell whether or not there's a 0 somewhere? And the answer is sort of a guess and check sort of method. So if we have a polynomial, f of x is a polynomial, the intermediate value theorem tells us that if I can find some value a where f of a is less than 0, okay, and then I can find a b, some other value, where it's bigger than 0, okay, then what this intermediate value theorem tells us is that there is a 0 between a and b. So if you can find some value of x where the function takes on a negative value, and you can find some other value where it takes on a positive value, then somewhere in between there has to be a 0 of the polynomial. And so let's look at an example of this. Well, let's look at the picture real quick first, because it makes sense, because a polynomial has a nice sort of smooth looking graph. So if we go out here and we find some point A where we have a negative value there, and we go up here and we find something up here, some point B, okay, because of that, I know that there's got to be a 0 somewhere in between those two things. Now there may be more than one, but I know there's at least one. And this can sort of start a guessing game of whittling down where the 0 possibly is. Maybe you try this point here, these 2 points here, and go, fine, maybe there's a 0 in between there, okay, because of the intermediate value theorem. So maybe you make another guess. You're like, well, is it still positive over here? And you make another guess. And you'd be like, oh, okay, so that still works. Now there has to be a 0 between A and this other value. So maybe you make another guess. And you can kind of wiggle your way down to where you have a reasonable guess for where a 0 would be. Now let's look at an example where we could use this. So let's look at the function x to the 4th minus 3x squared plus x minus 1. Now, looking at this, if you were trying to find where a 0 might lie, okay, so maybe I'll say find an interval that contains a 0. Well, we're looking to plug in values for x where one value we get a positive number, another one we get a negative, and then we would be able to say that somewhere in between there's a 0. So if we're going to pick values, I mean, it might be convenient to pick 0. 0 is always nice when we plug it into a polynomial. So when we plug 0 into the polynomial, we get 1, or negative 1 rather, right? Because 0 to the fourth minus 0, 3 times 0 squared, plus 0 minus 1. We could do something, okay, so let's see what happens when we plug in 1. So we'd have 1 minus 3 plus 1 minus 1. So that one's not nearly as nice because when we do that, we'll get negative 2, negative 1, negative 2. So we didn't change signs there at all. Okay, so let's maybe go up a level here. Maybe say that we've got look at f of 3. So f of 3 would be 81 times 3 times 9 plus 3 minus 1. Okay. So it's 81 minus 27 plus 3 less than 1. So we would get 54, 57, 56. But this is good at the moment because what this tells us is if we look at 1, we have a 0, we have a negative number here. F of 3 is a positive number, so at the very least we know that there is a 0 between 1 and 3. Or 1 less than or equal to x less than or equal to 3. And maybe we didn't have enough faith that I just jumped the gun because I was worried I was going to get another negative number. Maybe we could whittle it down more. Let's see what happens if we plug f of 2 in. So if we plug f of 2 in, we get 16 minus 12 plus 2 minus 1. So we get 4, 6, 5. So this is even better because if we look at this now instead of looking between 1 and 3, at 1 we're negative, and at 2 we're positive already. So this tells us that there would be a 0 between 1 and 3. We already said that. 2 is now the one that there is some x bigger than 1, less than 2, that makes this function 0. And this intermediate value theorem can help you find zeros if you don't know what they are.